Linear programming, model formulation. Introduction. What is linear programming? Linear programming or LP is widely used mathematical modeling technique designed to help managers in planning and decision making, relative to resource allocation, and technique that helps in resource allocation decisions. What is programming? Programming refers to modeling and solving a problem mathematically. Examples of successful LP applications. First example is development of a production schedule that will satisfy future demands for a firm's production and while minimizing total production and inventory costs. Second example is selection of product mix in a factory to make best use of machine hours and labor hours available and while maximizing the firm's products. Third example is determination of grades of petroleum products to yield the maximum profit. Fourth example is selection of different blends of raw materials to feed mills to produce finished feed combinations at minimum cost. Fifth example is determination of a distribution system that will minimize total shipping costs from several warehouses to various market locations. Requirements of a linear programming problem. All LP problems have four properties in common. First, all problems seek to maximize or minimize some quantity, which means the objective function. Second, the presence of restrictions or constraints limits the degree to which we can pursue our objective. Third, there must be alternative courses of action to choose from. Fourth, the objective and constraints in linear programming problems must be expressed in terms of linear equations or inequalities. 5 basic assumptions of linear programming. There are certainty, proportionality, additivity, divisibility, and non-negativity. In certainty, numbers in the objective and constraints are known with certainty and do not change during the period being studied. For proportionality, it exists in the objective and constraint, and constancy between production increases and resource utilization. In additivity, the total of all activities equals the sum of the individual activities. In divisibility, solutions no need to be in whole numbers or integers. Solutions are divisible and may take any fractional value. For non-negativity, all answers or variables are greater than or equal to 0. Negative values of physical quantities are impossible.
Steps in LP formulation. The first step is completely understand the managerial problem being faced. The second step is identify the objective and the constraints. The third step is define the decision variables. And the last step is use the decision variable to write mathematical expression for the objective function and the constraints. Modeling formulation. The first part we will look at objective, which is to maximize the profit. The Crystal Light Company is expanding its operation and attempting to expand its sales territory. The sales manager has a group of experienced salespersons who are each paid 600 per week. He is planning to hire new trainees who will be paid 350 each per week. From past record, an experienced salesperson can generate 10,000 worth of sales per week. A new sales trainee can generate an average of 6,000 worth of sales per week. The company has budgeted 2,000 for a training program for the new trainees. The estimated cost of training program is 250 per trainee. The budget for the total salary is 4,000 per week. The company has decided that the sales force should be limited to a maximum of 10 salespersons. The sales manager would like to determine the optimum number of experienced salespersons and new trainees he must employ in order to maximize the company total sales per week. Formulate this problem as a linear programming model. First, what we have to do is to find all the important information. Find all the important information. The highlight color sentence will represent the objective and the constraints. The sentence with the green highlight represents constraint 1. The sentence with the yellow highlight represents the objective of the question. The purple highlight sentence represents the second constraint. And lastly, the blue highlight represents the third constraint. After we have defined all the constraints and the objective, we have to write it in a modeling formulation. Next, we will look how to define the decision variable. The decision variable will be represented like this. S1 equals to the number of salespersons and S2 is equals to number of trainees. Define the objective. The objective of LP modeling formulation will be defined like this. Maximum Z 10,000 X1 plus 6,000 X2. Define the constraint. Lastly, the constraint we have to write like this. Subject to 600 X1 plus 350 X2 less than or equal to 4,000. 250 X2 less than or equal to 2,000. X1 plus X2 less than or equal to 10. And finally, the X1, X2 greater than or equal to 0. This expression is compulsory. We also can formulate the model using the objective to minimize the cost. A hospital would like to use two supplements R and S to provide sufficient vitamin A, B, and C to its patients. The information for the amounts of the vitamins required is given in table 3.1 below. Formulate this as a linear programming model. Find all the important information. The objective of this problem is cost per gram equals to Rm 2 ringgit per gram and Rm 2 ringgit per gram. The first constraint of the problem is vitamin A, where the supplement is 30 units and the supplement S is 20 units. The second constraint of this problem is vitamin B for 40 units of supplement R and 50 units of supplement S. The third constraint is vitamin C for 10 units of supplement R and 20 units of supplement S. It is important to know how to use the inequality for LP modeling formulation. For maximization problem, we have to use less than or equal to. And for minimization problem, we have to use greater than or equal to. Define the decision variable. The decision variable will be represented like this: X equal to number of supplement R, Y is equal to number of supplement S. Define the objective. The objective of this modeling formulation is minimum C is equals to 3x plus 2y. Define the constraint. Constraint will be represented like this: subject to 30x plus 20y greater than or equal to 200, 4x plus 15y greater than or equal to 180, then x plus 2y greater than or equal to 120, and inequalities x1, x2 greater than or equal to 0 is compound.